Alright, welcome everybody. How are we doing? How's it going? So, just get this all plugged in. Oh. Welcome Phoenix Firewings, how you doing? Welcome. So, end of last stream, we got some UI rendering. But obviously not any like specific widgets or anything, it's just more the pure building blocks you'd use to render UI itself, right? So we just got a couple of rectangles, got a sphere, and got showing some transparency as well. So that's proper cool. I want to add 2 more different types of rendering. Or 3 more really. We want to get like a rounded borders. Oh, we also even got like did some anti-aliasing for this sphere as well, so it's not got any sharp edges or anything. Yeah, so that was a really good last stream actually. Okay. There we go. So in this stream, we're going to start off with a rounded box. Then we're going to do textures, get textures working, and then we'll get font rendering. So we should be able to do that all pretty quick, because we'll just do the easiest solution for all of them. I want to restart this album. I'm sorry. But I want to listen to it from the beginning because it's great. Okay. So basically we do the most terrible and stupid way of rendering UI right now. We are going to be trying to optimize this. We might touch on the optimization at the end of this stream, but today we are going to be writing performance testing code to be able to test how long the shader is, so we can actually and write good, just put a bunch of text over the whole screen and just show how much we can actually improve the performance with the optimization we will do. So the current way we do it is we basically have like a storage buffer of draw commands, and per pixel in a compute shader we just go over all those draw commands and we render front to back, so that the draw commands have to be sorted front to back, and as soon as it if the alpha is opaque, then it will break out the loop. So that is already an optimization or that's already an yeah, because that stops you from iterating over the whole list, right? So that already optimizes things. But yeah, so we did the we did the ABB. We've done the circle one. Even got some alpha blending in there. Sorry, some anti-aliasing in there. And so we'll probably just start with this ABB rounded next. So we'll probably just use a sign distance field function, because technically a lot of these are just sign distance field functions anyway. Or this circle one is. And then we'll do this glyph texture, then glyph, and then do the performance testing code using Vulkan, and get back like how long this shader actually takes to render a full screen of text. So let's just run that one more time. There we go. So let's make this green one with rounded corners, I think. Well, how about the purple? Yeah, the pinky purple one, we'll do that. By the way, why using a compute shader over standard rasterizing? So the reason is because for simplicity, basically. So it's kind of a challenge for this whole project, is like, can we... So if you have tried to use like the Vulkan API, you realize it is very complicated. And most of the complication actually comes from the traditional rendering API, like So basically, we're just trying to see if we can do a whole 3D game without using it at all. So this is a whole graphics API, and it's basically complete. It's about 200 lines of code, or it's our own GPU API, right? It's 200 lines of code for the header file. And so we could just have a way to like create buffers and create textures. We have a way to upload and read back from resources. And we also have a way, there's some extra little fun bits that I've got in here. So it's basically a way of, oh yeah, this also copy just means that it copies it and allocates some memory for it, I think. Oh no, it automatically copies it to a pointer place rather than reading it directly from the readback buffer. This one here is like a little fun thing where it's like the GPU can produce commands for the CPU to execute. So it's like it's a CPU command. I call it the readback command buffer, basically, but yeah, nothing much. And this is our commands right now. So we have a very simple synchronization code. And then you can just say sync on this resource. I'm going to read from that buffer. I'm going to write to that texture, and then you say dispatch. Basically, that's the whole API between. So yeah, we're just seeing how simple we can go, basically. Because if you use the traditional rasterizing API, you've got like render passes, you've got frame buffers. Obviously, you can get rid of frame buffers, you've got the sync code, and you've got there's all these different like concepts that sort of like interact with each other, and it gets really complicated. But yeah, so it's a far more simple API if you just use compute, and it's kind of more low level as well. But yeah, I'm not sure how well this will map to like running on like a mobile device. You'd have to write a very specific renderer for that one as well. Oh, Paya, 2 years. Wow. Thank you. Thank you so much for that, sir. How you been? So there's like a nice list of 2D sign distance field functions. So those who don't know about sign distance fields, basically, it gives you the distance to the edge. So it would be negative inside and positive outside. So there's just functions for these that we can just basically borrow. So they're in 2D and 3D basically. So you can get some 3D ones. But yeah. These are really handy just for doing like if you're gonna render some UI, they're super handy like ways of doing it basically. I'm not sure how. Yeah, I'm not sure about all of this though, but maybe sometimes. But anyway, if doing a bot around it, is it easy to do around a box? No, I think there's a simpler equation. I think there's a simpler method. There must be. Let's think. So it's doing some swizzling thing, and then you can define the radius for individual corners, which is pretty sweet. So really, if it's all the same, this gets simplified, which we're going to do anyway. So let's just take that, simplify, and I think that would be good enough. We can always change it. So R meant radius, right? Best to store it as a constant. So if we go to our little draw command thing, that was in UI. Right, so it's draw command type, color, center position, half size. we don't really have enough for a radius, do we? So we've got to actually add one. And the fun thing is the circle is already using this one to store the radius in anyway. Oh well. That'd be fine. Okay. So it would just be like command.radius. And this would be like the distance. And then pass would be distance is less than or equal to 0. Whoa, Provod. Welcome, welcome. Thank you so much for the raid, sir. How's it going, everybody? How's it going? So we're currently working on a game from scratch, basically completely all written from scratch without an engine. We're simply just doing some UI rendering. So we're just doing we're rendering everything using compute shaders. That's the kind of aim of the project. So we're just currently working on a rounded box. We're going to get some textures rendering and some font rendering in, just dead basic, like bitmaps basically. And then we're going to do some performance testing on this compute shader and then optimize it. So that's the plan for today. Hopefully we can start optimizing today. That's the aim. But anyway, if anyone has any questions about the project or anything, just feel free to ask, and I'll happily dive into more detail. But yeah, compute shaders only all the way. What I use Windows creation. I use Oh, sorry. I was just thinking about Windows because we just did a port to Windows. But yeah, we use X11, just raw xlib. On Windows we just use the Win32 stuff, right? So this runs on Windows and Linux as well. And we are planning on keeping both working basically. Right, so it converts from GLSL to C. What do you use for font rendering? So currently we don't use anything, but we're just going to do bitmaps. Just because it's going to be the easiest thing to do, right? We don't really care about supporting every language at the moment. We don't really care about all sorts of things. Even if it's a little bit blurry, it's just got to be enough. So for now, we're probably just going to grab like a pre-rastered like bitmap, like as in like something like the code page 4.3 whatever, you know, that 437, that one. Just grab that one. It's fixed size at 8x8 pixels. Just grab it, you know, render it, done. So the thing is, in future we'll probably just use like STB true type, or maybe wait, what's that other one you can use? My mind's gone completely blank. But yeah, there's another library you can also just use. It's just as good. You know, rasterize the font on the CPU and just upload it into some sort of cache. I'm not sure if we're bothered in sign distance field fonts, to be honest, because they have their issues. They're cool for like in-world stuff, but screen space stuff, they're pretty naff. Or for small text. But yeah, I've had some ideas on how you could render font, like do something more like just untraditional, but it's a lot of work, and I've already sidetracked and made like a custom shader compiler, so I'm not doing any more sidetracking anymore, right? I've used Nano VG in GUI, but currently using bitmap. Yeah, it's not like something I would use if I was gonna like ship, unless I really wanted this style. Like this is like from like old IBM PC, and it's just fixed 8x8 pixels, and it has to be like integer scaled. Well, it's not 8x8, is it? Sorry, I'm getting it completely wrong. It's 8 by. Wait, I forgot this. Right, 9 by 14 pixels. Sorry. And an 8x8 character font. Oh, maybe there isn't. Okay, I don't know. Anyway, we'll just find one. But it's mainly just placeholder until we get more of a proper solution, because it's just like dead easy to do. So P would be the point inside or relative from, because that's the way this thing works, right? So the way this works is P is like P is the point relative from the center, basically, of this. And then B is like the box extent, half extent, something like that. So 0 is origin. Sorry, center is origin. 0, 0. So how do we get that in this? So to do that, we've done it in the circle, right? Subcenter, chord subcenter position. That's what we want. So you call this like float to P. Looks very Undertale-like. Yeah, I'm not sure what Undertale used, but that's a really great game. I love Undertale. It's beautiful. F32 times 2. Sub F32 times 2. B is the box extents. We'll figure that one out. And then add S for scalar, because that's a scalar at the end. Right, so B, what is B? B is the box extent. So we've got half extent. So we already got that. It's half size in the draw command. So that'll just be command dot half size. So that gets you this thing called Q apparently. Right. So F32 max, right. Point F, because we want float. Len. F32 times 2, all my days. Let's fix that up, good. Max, S, F32 times 2, Q, and I should fix that. Right, so that's scalar. That Len gives you a scalar back, and so we can use the standard operators for that. Sweet, then that gets you distance, and voila. So let's give this one a go. So we've got to plug this in, right? So let's go to the CPU code, GFX or C. So we've got where are we going? So we've got some temporary draw commands. They're ordered from front to back. So that's something that's going to be in this UI limitation. So the pink one is this one here. So we're going to change that to rounded. And we're going to add a new one. And it needs to be called a radius. Now, the radius, I guess, is going to be in pixels. So let's just say 25 pixels. I don't know. Let's see how that looks, shall we? Right. So for some reason the alpha is buggered up. Well, no, sorry, it's just not even rendering, is it? Oh, because we didn't set source color. Didn't unpack the color. And there we go, rounded corners. So the problem is the aliasing is like, we've got that anti-aliasing problem again, isn't it? So if you look at the circle, let's get this. Let's open up in Krita. So, new file from the clipboard, please. Oh, come on. Right. So, see this circle we gave it anti-aliasing in the shader last stream. So we kind of need to do the same thing to this, right? Because look at these jagged edges, they're horrible. We only really need to do this for the because these are fine, right? But for this one, we kind of need to do it. So let's fix it up. You know, I wish that wasn't so blurry when you zoom in. Like, it's horrible. Right, so how are we going to do the anti-aliasing? Why have I got my meter readings thing open? Damn these things. Why are you open? Right. So the way that we did it last time is we basically like... Yeah, so I think we need to do this sign distance thing, but with the extended... with the radius extended by 1 pixel. And then if they're different, then we need to do the anti-aliasing. So this is the sign distance equation, right, for in this rounded box. So obviously it's got a lot of reusable bits to it because radius only gets added here, right? So really we could have this cute, like, oh no, not really. That's the only reusable bit, isn't it, here? Then we just need to add 1 pixel to it. Damn it. So let's just try it out and see what we can do. So let's call this one D for some reason. Put D in there. Then you call this like Q2. And you probably want to just compute like distance 1, distance 2. So it's be Q2 to... I guess we can optimize this later if it becomes a problem. Then take radius plus 1. So we probably want to have like a radius... radius plus 1. So something like that, right? So what we need to say is like, if it's a pass, if pass, we can do that. And then we need to compute we basically need to do the same AA thing as we did last time, right? So we need to compute T. It might not be too easy actually. Let's just get Milton out. Wait, we have the distances. From the edge. Yeah, so I guess like, okay, so if we have the distance from the edge, that'll work. That was my circle, it's lovely, right? So we have more of like a rounded box. So the idea is when we're doing this anti-aliasing on these edges to stop getting these jagged edges, we take two distances, right? So one with the radius. Wait a minute, do we want radius +1 or -1? Because -1 gets you further out, right? Whereas radius +1 gets you more inward, doesn't it? So that's kind of wrong. So we want radius -1. Right? So you want radius -1. So imagine if these pixels are chunky or whatever. So you got one pixel here, and then you've done the radius -1, and that gives you a pixel here or something for some reason. So these distance values, this distance would be -0.5, and this distance would be +0.5 because it's on the outside. So this is the perfect moment where we can make the AA thing work, basically, or something like that. So if the two dots are on the inside, then obviously it's not going to do anything. It's not going to make it transparent at all. So you got distance of positive and negative. The distance to be positive. Yes, if that one is positive, then you want to do something. So if distance 2 is greater than, then you kind of want to generate like a t. And do a lerp of some kind. So how are we going to make this t value? So you're going from, so you're lerping from 0, so completely, transparent, to whatever the source color alpha is. So how are we going to do that with the distances? Well, the distances are 1 pixel apart, right? See, we could just hard code it to half transparency, but then it won't be as good. So what makes it? So you want to say like how much is the one on the inside? So you want to say like how much is this one on the inside? Yeah. So the closer this outside point is to the edge, the more opaque you want it to be, right? And then obviously the closer this one to the edge is, the more transparent you want it to be, type of thing. Because they're both it's the same distance apart all the time. So if they're the same distance apart, you probably just need distance 2. So with distance 2, so distance 2 will go from basically 0 to 1 in a way. So you definitely just want to like min that. Min distance 2. So 0 means it's like on the edge, which means you want it to be more opaque. So you basically just say 1 take. That, right? And then, or we could have just swapped these the other way around. We can do that also to make it go backwards. Because then that avoids the one take. Ah, isn't that good? So, wait, why didn't it work? Oh, sorry, min, and I just did. Right, what would I min with, 1? Because we already said if it's greater than 0, right, so we don't need to clamp it. Right, let's try that. I don't know, I don't think that looks any better. Should we have a look? We gotta bear in mind this zoom feature is a bit blurry anyway. But yeah, we would see more pixels lit up, I think. Don't think that's good. Right, no worries. So just a little bit off somewhere then. So make sure we actually compiled it first. Yeah, it didn't look as good still. You can see it's a bit sharp. So the first question is like, do we land in here? Right, so how do we know that? Well, we have printing in shaders, so we can simply just do like do something like that. I don't know what I called it. We need to find that out. Cheap. That's hprintf. Yeah, but didn't we? I made a shorthand version of it somewhere. It's been a while since I've used this. GPU. Here it is. No, come on. Maybe not. Here it is. Yeah, GPU hprintf. Okay. That prints out to our little buffer, and then we read that back to CPU, and then just display it in the terminal. Right, let's place that one in there. So it clearly wants more things, so let's just give it a 1. Maybe that'll bug out. I don't think it's landing in there because it would show up. Should we do this, right? And watch it just blur, like just throw up in the terminal. There, it's all there. See? So, and it goes laggy as crap, right? But yeah, that's cool. So we don't actually land in here. Why is that? So I thought the -1 would have been it, but maybe it's not enough. Maybe. Should we try the +1 and see what happens? I was thinking that it was -1, but maybe it is +1. Oh, it does hit it because it's putting stuff out in the terminal. So I was wrong. Okay. Am I wrong? Like this. Because like the smaller the radius on the rounded corners, the the higher it is up here, right? Yeah, I do upload the streams to YouTube. Go to... Yeah, I just film on a different channel. Because I was hoping to do some more devlogs, but you know, time. And that. I think I might... When the graphical things come in, I might do... Yeah, just report on some of that stuff, basically, because it's easier. We'll see. Awesome, no worries, it's all there. The input stuff went on a little long, but we did get controllers working on all... Oh, it's been the longest thing so far. The GPU backend went up super quick. I was happy with that. But we got controllers working on Windows and Linux, so if you're interested in learning all that stuff, it's interesting because I've never done it. But it might not be everyone's cup of tea, that is. But yeah, it's all there labeled, so feel free to dig into the bits you like. But yeah, got all that working, which is great. I'm confused then. So why is that? Unless I'm getting the distance that checked the wrong way around, right? You know, I might be negative outside. Oh no, it won't be. Negative is inside. Because if it passes, we'll see it. Because if I did it the other way around, right, it would just make the whole screen that way, right? Shoot, it just crashed. What have we done? So we're just in the border here. Why are we just in the border? Is it something to do with the thing we've just done here? Yeah, that's what I was expecting to see, right? So if you... Yeah, so we're on the side, it's just the right way round. The interesting thing we just saw is that this lerping code is working. Now that we flipped it the other way. Oh! Wait, do I have to render it a bit bigger? I remember that with a circle. What do we have to do with a circle? Pass if it's greater than... Radius +1. Yeah, so we need to make it a bit bigger, I think. That's the problem. So ready, we need to say 1. Oh, I think those corners look good. I can see it from here. And it's hitting the test. Oh yeah. Right, let's get rid of the printf then. So if we run that now, let's do a capture. Copy that. Oh yeah. And then I want to do a Krita. I'm so glad they fixed their compile times. No, sorry, their build up times. They're just horrendous. So long. Oh, look at that AA. Oh, it looks so good. So that's really great. I'm happy with that. So we should really document this code that we've put down because it does look a bit like, you know, gotta kind of know what you want to do. It's gorgeous, isn't it? Hey, they're not so red. How you been? Nah, it's cool. It's cool, no worries. No worries. So should we document this circle one just for a sec, and then we'll document the rounded one. All right, no, let's start simple. A, B, B, right? So This one is a distance from. You get the difference. We're just checking if like point is right. Check if point is inside ABB. That's all that code is. So difference or maybe we could say like center of ABB or vector from center of AB to point, right? That's so the same thing here, right? Vector from center of circle to point. It's kind of like an absolute vector, isn't it? So absolute. Absolute vector. Oh yeah. Then you've got like squared radius. Work in squared space for speeds. For all of the speeds. It's more applicable here. Hey, they said who? Doing good, doing good. Good to hear, not so red. Good to hear. Yeah, man, doing good. Just been looking after the baby, throwing a house party, and relaxing. It's been about it for me, but yeah, things are going well. Just been just doing some UI rendering at the moment, just getting all the rendering primitives together. Then we're gonna do some get some performance metrics using Vulkan, see how terrible and slow this shader is, and then make it better. But yeah, I think it's going good. So radius +1 for the anti-aliasing to work. So that's just the color. That's just how much anti-alias by done. Cool. I think that's good enough comments. It's just to help out. This is simply just a right. Simply, right? All right. This is a signed distance function for a rounded AAPB, but sort of like done twice, repeated once, for some AA. Anti-aliasing on the rounded edges. Corners, something like that. So we just want to say like, so that's an equal to 1 pixel. So anti-aliasing. That'd be fun though. Cool. Right, I think that's a good. That is good. That's some good enough comments. I think we could go more crazy, but I think that's good enough. Right. Um. So what's next? Well, we want to get texturing working. Right. We want to get glyphs rendering as well. Dead simple text rendering. Nothing too complicated. Nothing too pretty, to be honest. And these are the last two different types of rendering we'll need just to do all the UI we want for now. I don't think we'll need any more for a long time, actually. Obviously, the glyph rendering will improve in the future. So, rendering a texture, what does that entail? Well, we kind of need a texture, right? So, how do we get one of those? Well, we get HCC texture 2D type T, which would just be, I guess, float. Something like that. So we could optimize this, that's for sure. Bring it down, share some bits and bobs. I'll think about that in just a bit. But I don't think we need to optimize it for a long while. This is probably not going to be the bottleneck. HCC intrinsics. Oh wait, when is it? That one. Where is this one declared again? Could have swore it's in here. Is it in texture intrinsics? Wait, I did it wrong. Classic. Read only texture, because we're not. Yeah, we need to be explicit about that. Cool. So we'll fill that in. It's just a 32 integer, just a resource index. So for this one, we're just going to use the logo, right? It's the only texture we have, but it's going to be sweet. Let's go to the good old workbench, go to the game event engine. We've got some assets. Well, the assets is just a logo. It's just my logo here. So we'll just put this one up on the screen somewhere. That's what we'll do. So basically, we just need to do like this AABB check. But then rather than just getting the color from color, instead, we're going to get the color. Hey, wait, why am I getting some static back? Is that? Oh, maybe it's just something in mind. No biggie. This is interesting. Is it immediate mode or no? Well, currently, it's nothing right now. It's purely just render code. Just because we've done a lot of like engine stuff, and I just wanted to get something graphical going first because we made a whole GPU API, compute shaders only, and we hadn't used it yet, so I just wanted to get to using it. And we got a whole shader compiler we've made as well, and it's like I want to have a bit of fun using it, So we're just doing that first, just doing all the fun bits first, and we are going to go with immediate mode purely because I find personally, again, it's a personal opinion, that for programmers, I feel that it is the best sort of like it's the best way to make UI for programmers. Like if you have some other people on your team, you kind of might want to like do UI. Maybe some other format could be better, but for programming though, it's the quickest, simplest, and simplest thing to implement. And you also can mix logic and layout together right next to each other, optionally. Which is kind of beneficial. So I do quite like the immediate mode stuff. I know quite some people like the retain mode, but yeah, I like the immediate mode stuff. Hey there, Frank. And hey there, Mr. Don't. Mr. Don't, I'm gonna call you that. Yeah. Yeah, the game engine's coming along good. It's a game without an engine, but the engine part of the game without an engine is coming along good. We've got the gamepad supporting GPU layers in there, doing some graphics now, getting some quick debug UI stuff in. And then we'll be doing some graphics R&D, I think. Be good. Be good. Hey there, Cassandra. Good to see you. Welcome, welcome. I'm just curious about how you're going to go about this. Wait a minute, let me just get something actually graphical up while I'm talking. Woohoo. I'm just curious how you're going to go about this, because ImGUI is high CPU usage causes problems because it rebuilds the UI every frame. Yes and no. It depends, right? Do you have a lot of UI? That's the first question. The second question is you don't have to run the ImGUI code on code on UI elements that are not visible, right? Yeah. And also like there's many different ways of building ImGUI. You can build it like the very sort of like stateless way, which ends up kind of feeling more hacky, but it has its pros. It definitely has its pros though, because it's more simple. But you can also build it the more the more sort of stateful way, where the UI system stores state about the widget internally. So I've done both. But yeah, I'll just probably just do the most simplest thing to start off with, and then maybe we'll change it as time goes on. And we can measure it as well and see what it's like. Unless you don't have much bugs in the compiler so far, that's cool. Hope I didn't jinx it. No, there's been like one or two. We fixed one. There was a problem with casting a signed or an unsigned vector to a signed vector. We fixed that. There's a problem with the preprocessor that we just like swept under the rug that I've forgotten about. And there's been another one as well. But yeah, I should really keep note of these ones that we've got because yeah, they're very small, which is good. But yeah. Yeah, I shouldn't have swept it under the rug basically. If I come across it again, I'm gonna write it down. Yeah, preprocessor code is not fun. Did not enjoy it writing it at all. It was really not enjoyable. But yeah, when we have a whole bunch of code written for it though, and we make changes, we've got basically a bunch of test code. So I'm happy to make changes with the more code we got. But yeah, I don't want to go back to the compiler for a bit. It's good enough for now. Yeah, so we just want to do like an A B B thing, right? And then if we pass, right? If we pass, we can set the source color. And so the reason why we don't set the source color here is because if so, we'll just be branching, right? It would just be quicker just to do this. Possibly. That's the idea. It should just be quicker to do that. But because if there'll be more expensive stuff in here like texture sampling. This isn't, wait a minute. Yeah, it's texture sampling without any MIP levels, so it'll be fine. You can't do it in compute anyway. It's got to be explicit. Yeah, I've got that all checked actually. So if you use the wrong sample function. So what are we doing? We kind of want to load. We want to sample. Yeah, but we want to do a sample LO. See, I forget these. Right. So we kind of did like a sample. Probably MIP bias with a MIP bias of 0, because like the problem is sample is going to automatically try and do a MIP, It doesn't work in compute because it uses like ddx ddy to get the derivative of the uv, the coordinate that you pass in, and based on how much that changes, it uses that to calculate the MIP level. So you can't really use it. So if you use MIP, but if you explicitly provide the MIP, wait, no, it's MIP bias. MIP level, this one you want to use, not MIP bias. Yeah, so you need to basically use MIP gradient, where you explicitly provide the ddx dy, or use the MIP level explicit one. So let's say MIP level G. That's the one I want to use. So, right, well, what are we loading from? So command texture. So that gets us back a color. And then we just want to multiply that, right? So it's mul f32 times 4, source color, and we multiply that with whatever the color is passed in. So this is going to be like a tint. So it's a way for you to like basically remove, well, not really remove color. You can also like make a color stronger as well. But yeah, you can sort of like remove color and make it more stronger if you want to. Which is kind of useful. So I think that should be good enough. So let's go ahead and actually sort of get that working. So where are we going to add this one? So it's front to back ordered, right? Circles at the front, got that rounded thing. So we could put it like, let's put it in front of this so it goes transparent and you see the logo up here. That'd be cool, wouldn't it? So we'll do this sort of texture. Color's just going to be fully on, right? Because we know that's going to work. It's just a multiply. It's got to be a square. So let's do square 100. And then we need to set the texture as well. We can set that runtime. So this is called every frame. We'll just set it up. So this is be careful. Draw commands to texture. Now we need to set it to the actual texture. So we had it, it's like logo texture. Oh, it's right here. So we load it up at the start anyway. So we just set it to there. Ooh, there's a thing we need to do. GPU, GFX. There's a function for it. Or GPU resource ID index. Pass in a resource ID gives you a resource index. You get that into the draw command, and the shader is just going to do a lookup in the shader for it. Cool. Fantastic. That ought to work. Kinda. Right. We'll have a look into that. Why didn't work? Preprocessor is fun for me, lol. Yeah, I'm not talking about like using the preprocessor. I'm talking about like implementing a preprocessor. Yeah, it just wasn't fun. It's basically like, you know, read the C spec, and then you'll find out that it's like in some weird alien language, which also looks like English, and then like it's impossible to understand what exactly they mean. And you basically are just better off like just seeing how every other compiler does it, and just make sure, just do whatever they've all agreed on, right? Because it's just, I'm sure they've been fighting over it for years. What resource did you use to write your compiler, if you don't mind me asking? Yeah, so I kind of don't know exactly where I've picked. Like, I can give you some resources, where to start off with, basically. I think that's a better way to address the question. So there's a thing called crafting interpreters, right? Oh my days, I can't find. There we go. So there's like, you can actually just like view the whole thing online. You can also buy the book to support the guy if you like it. Take a look there. It goes over sort of like, it gives you a sort of a mental model on how to think about building a compiler and actually making a whole virtual machine as well. This is actually very fun. Although like building a virtual machine is kind of pointless, it is a very fun exercise and is I actually quite like doing it. I've built a few of these little things. But yeah. From there you can understand things and you can sort of like probably go off and know how to search for different areas in compilers. To be completely honest though, I've completely avoided understanding what like grammars are and like all this theory stuff that you might see online. I don't know. I just programmed one and got one working and did lots of research and did it sort of that way. The sort of non-theoretical route, right? Sheesh Corey. Hey, saw your stream on the main page. Are you going to make this Wayland native? Probably when we actually go to release something, probably make it Wayland native, because then is, that's when it will actually check this brightness. Right, here we go. Sorry. Wait, why would I such a scrub? There we go. Why don't we make Wayland native? Someday. Yes, but right now I'm using X11. 50% of Linux users or more are using X11, maybe more, right? Until most people are using Wayland and basically every main distro is there, I will do a port to it, right? Because everyone in the world of Linux basically is using that sort of latest. Everyone moves over quicker compared to Windows, right? Windows people stay on like Windows 7 and whatever, right? And they have like really old operating systems. Talking about compilers, I'm almost done with my type checking stuff. I still need to do very small stuff like checking if the operand is an R value in some cases. Yeah. Nice, fancy. You write what sort of compiler are you writing? Is it for like a language? What sort of language is it for? Yeah, most are still next level on the Wayland has been gaining popularity, especially because the major distros are default to win on Intel AMD chips. Nice. Yeah, we get to sort of default and oh wait, shaders ain't compiled. And just get a bunch of bug reports, right? And fix all that good stuff. Oh, what's wrong here? Incorrect number of parameters, right? Yeah, I just passed in the texture and I was like, that's how you sample a shader, a texture, right? No, you need stuff, you need things. Do we have a sampler? No. Yeah, I don't have a sampler. Should I just do a texture load and just be like, screw it? I think I might. So yeah, we'll make like a UV. Alright, how are we gonna make this UV? That's a good question, isn't it? So you've got this rectangle on the screen, and you need like a. What's the easiest way we can do it? So we've got diff, but that's like an absolute chord. But you do have this sort of thing here. So coordinate is like the pixel on the screen. Center position of the center position of this rectangle that we're thrown up. Now, so you take the difference between those, it gives you a sort of a vector from the center to the coordinate on the screen, which could be used for something, right? So if you divide that by half size, that can give you, -1 to 1, and then you can turn that into, it gives you sine normal. You can turn it into unsine normal, right? So I think that's probably a good route to go. So we call this like S-diff for like signed difference, I guess. And of course, one like U-diff, just so it makes it easier to understand what S-diff is. And then when we're in pass, we can do the extra calculations. So we could probably just, so you can do like S-diff divided equals, or just divide. Wait, I can't, it's a vector, isn't it? So we're like div f32 times 2, command half size. Then we'll end up just doing, so that gives you -1 to 1. Then you basically just convert that from sine normal to unsine normal. So we just say like UV equal that. So this would just be, let's call it snorm, good old snorm. And then we want to say UV equal, so you basically like multiply UV by 0.5, and then you add 0.5, and then his buddy U norm. So then with that, we've got the actual thing. So we need a sampler. We haven't actually got samplers in the GPU API yet. We kind of forgot about those because we haven't actually done any of that yet. So for now, what we're going to do is do something even worse. We're just going to say load texture. And for that, we just need, oh wait, this is actually, let me turn on a light and get some more light in the room. Sort that out first. Cool. So you consider making it native eventually, though. Sweet. Yeah. Yeah, I definitely just, it's not too difficult, I think, for now, because I haven't really added too much X11 specific code. But if we start doing stuff with like monitors, multiple windows, full screen mode, yeah, it's going to require some more X11 code. But yeah, the more of that we do, the more if statements basically. But yeah, I'm just experimenting for now, but I've got a Rust-like syntax with type system simplicity. Fair play. Nice. So, see, we don't have the texture size here, but there is a function. There is a built-in function into SpearV which can get you the texture size, and I don't know if I brought that in to the compiler, like the HCC. I just don't think we did it. So texture. All right, 2 seconds. Let's see if we've got the intrinsic. Right. See, I don't think we did a texture size. But yeah, there is an intrinsic to get that because, you know, in the texture descriptor, like the size is stored in there most probably in every implementation because. Yeah, and I'm sure they just store it in there. But yeah, see, we could implement samplers, or we can. You know what we're gonna do? We'll add sampler support in a bit, but for now we're just gonna hard code it. right? Just hard code it. Oh shoot. Sampler, then wait, what was it again? UV. Shoot. Level 0 mip, please. That all good? Right, sampler's not declared, is it? Good. Sweet. So we comment that one out. And then what I want to do is, for now, do load texture. And this one is just going to load from... So we're going to multiply UV by 256 to do add sampler support. So for now we only have one texture, so just hard code it, right? Good. Right, so this needs to actually turn into a unsigned. So U32 times 2 splat 2 that ought to work. What's my compiler saying now? Oh, it's a scalar. Shoot, scalar param. This is moles. Fantastic. Right, that'll work. Oh, texture sampling. There we go. So it's obviously hard coded, but voila. It's not even sampling. It's just load pixel at chord. Now it's going to be off by 1 at the end, and that is because we go from 0 to 1. Basically, right? So obviously when it's 1, it's going out of bounds, which is not good. So there's that one, at least. Wait, but that means we've done it, the UV is wrong anyway, because it should be like 0.5 or whatever. So you need to offset it by a pixel, right? Shoot. So UV going from 0 to 1 is not good, because you need to offset it by, you need to put it in half a pixel in. I have a question. If I were to create a Rust clone without a borrow checker, do you think I will be assassinated? Nah. I think some people like unsafe Rust anyway, basically. But yeah, that'd be funny. That's quite a troll move, you know. Just like people praise Rust for the borrow checker. So if you used to create a Rust, which is basically without the borrow checker, that would be funny. I remember when I have that opinion, people are just like, but that's the reason why you choose Rust, isn't it? Troll move. You know, it's like you just open a door of like thinking for them. There's a that's so how are we gonna get this UV? What do we do, right? So if you take off half a pixel before you do the division. Wait. So you do the division and it gives you -1 to 1. So yeah, so if you take off the half pixel of on the sdiff, and by taking it away, Problem is if it's at 0, you see. That's the problem with it. So you kind of want to like minute. Minute with half size. Right. So you clamp it. Right. Clamp F32 times 2. Or F32. S diff. Stiff. X. Command half size. Take 1 pixel. Right. Do the same thing for the Y. Wait, do you want to do a min? No, it's clamping it, sorry. Dot X, dot Y, 0. So, yeah, but it's signed. So you want to do, and the negative of that. Right, so that will give you basically, yeah. Cool, 1 pixel off. So you do that so the UV is calculated correctly. Let's see how that works. Sweet, so now we haven't got that 1 pixel off on the right hand side. Right, so the UV doesn't really go from 0 to 1. It goes from like 0 point whatever, which gets you half a pixel in, right? So if you were to have like a box, so it's a lovely box, and it's made up of a bunch of pixels, for instance. You want to say like 0.5 in there, you know what I mean? Not 0.5, but yeah, half a pixel in. And that's where we're limiting this to actually be. So when we do the division, it goes from like whatever that is to that half pixel in there, basically, you know. So the UV is correct. So we kind of put a comment there because that kind of looks a bit alien and maybe it can be done better. So we kind of want to say just, you know, make sure the UV will be, wait a minute. Yeah, that's clamping it. That's clamping it. Is that doing it wrong? Yeah, I think clamping it might be doing it wrong because you'll get a repeated pixel as opposed to stretching it accordingly. I think that's, yeah. So maybe we'll fix that. I'm thinking about doing that for so long. It'll be funny. Awesome. Perhaps exit. How you doing? Welcome back. How's it been? How's it going? So instead of doing that, maybe you move the half size down by a pixel. No, you increase the half size by a pixel. Is that right? Is that the same? Yeah, because clamping means you'll like lose information, right? You're just sort of like cutting it off. Whereas if you're changing something from or everything up by 1, it's all going to be affected in the same sort of way, right? So I think what we want to do is probably make another local so we can put a comment by it. And I think what is better is if we say that, right? So then I think we want to just say like, so if we divide by that, then everything should be Let's just try it out. Right, that's still good. The logo is still showing without that extra pixel there. Is it right though by being a whole pixel? If I did 0.5, that's going to be wrong, isn't it? It's probably rounded up. That still kind of works. Let me do 4. Really, if you increase it by 0.1, will it really work? Okay. Then if I don't increase it by anything, then we get that 1 pixel that shows up here. Okay. So let's think about this. So half size, if you add 1 to it, like 1 pixel, you do the division. If say this used to be like 256, you're doing like 256 divided by 257, which will get you that, right? And that is not quite 1. You kind of want it to be like half, right? So let's imagine we have yeah, but it's not going to work for 0 though, right? Because you want, oh no, it'll be negative, wouldn't it? Negative 256. Right, how can we work this out easily? So you probably want to do like 1 divided by 256. So that's 1 pixel in UV space. But what you want is half a pixel off. So half a pixel off is that. Let's jot that number down. In our favorite text editor, not. So that's the half pixel that we're looking for. So if we have 256 divided by 257, remember this is in signed space, meaning it's already kind of 2 times more anyway. Wait, is that right? Wait, what am I doing with am I doing that right? Yeah, so it'd be times by 0.5 plus 0.5. Okay, so that's in signed space now. So by being in signed space, if we add this number once and it reaches 1, it's fine. If we add it twice and it reaches that number, it's off by a whole pixel instead of half a pixel. So let's add this number. Kind of went a bit over for some reason. What did we do wrong? what did we do wrong? Or maybe it should have been in signed space. Because we did the... Oh, it's in the division in... Yeah, it might have to be done in signed space. Okay, right, let's do that again. It'd be a lot more far more simple, right? So it's 256 divided by 257 plus this half a pixel plus, okay, then plus another half pixel. Yeah, I don't think that's right. Okay, so that's not a good way of doing it. Because both of those things have proven wrong. So maybe we just need to do 1 divided by half size, and then sort of like... How are we going to get this UV right? Maybe I should be doing take one instead of add one. Add one seems wrong. No, because if I do take one, then the UV can go over by one. You know what? I've been thinking about this problem too much, but for now this will do. Inclusive. Yeah, we'll fix that in a bit. I've just been thinking about the problem too much and kind of just, it'd be easier to just take a break and then I'll just, come up with a better solution. Right, so let's just say textures, that's done. Got 2 to-dos to sort out, but we'll come back around and do that. There we go, textures. Ta-da! Ah, Bambuka. Oh wait, Bambusia. Maybe that's the way you say it. Welcome to the stream. Cool. Right, so let's do this glyph thing. Right. So what we're going to do for now is use that code page 437 because it's like pre-rastered, fixed size, simplest thing to do. In future, we'll probably have some font atlas and all of that. That's more complicated and is effort. And the effort doesn't really give us any results that's going to make this better for us to develop, right? It might look better, but I'm fine. Hey, Swing Funk, how you doing? And Egotist, welcome guys, welcome. So for now, pre-rastered font will be fine. I think there is an 8x8 version. Can we get that one? But maybe it's not. Right, there's an 8x8 one here. Let's nip this one. That's what I want. What's 10x10? Right. Assets. Ten by 10. Bam. Chuck that bugger in there. And here we go. So just going to load another texture. Right. So when we start our graphics backend, we're going to add a new resource ID. This is going to be our font. And simply, this is the font. Texture 2D 8888 RGBA UNORM, right? How big is it? Well, it's ASCII. So 16 times 10, 160 maths. 160 by 160. I could have just done that in my head. But anyway, I had to kind of spell out the inputs. So anyways, and there we go. So that's going to create a texture, but it's not going to actually have anything loaded, is it? So what we need to do is duplicate this guy. So I could make into a function and have reusable code, but doesn't matter. I kind of forgot. Right. Failed to load image. So obviously if we add like tons of these and see a common pattern, it might be better to make reusable code, right? But anyway, for now this is fine. And then we upload the texture to the GPU and kabam, we're done. Obviously it doesn't get uploaded until the first frame starts, but That's me in maths exams. Got to check if 1 plus 1 still equal 2. Exactly. As soon as you... like, I grew up with a calculator and never bothered to, you know, especially on stream, when you like go into interviews and you just like feel like super dumb and all your sort of like brain cells just like run away for some reason. Um, that's how it gets like on stream sometimes, or when I've like thought about a problem too much. And I end up just busting out open the calculator for the most like basic stuff, and it's so funny. But yeah, yeah, but it's 16 by 16, right? So 16 times 16 is 128. I'm pretty sure. No, 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 it's 256, isn't it? But yeah, this is extended ASCII. Like it's a square image basically. Yeah. It has all of these things which non-English speakers are like, what are these? Sorry, which English speakers are like, what are these? Um, it has also some extra bits as well. We obviously only care about these guys. Um, yeah, and that will be good enough for now. You are. So load that texture in and kabam. So let's put a glyph somewhere. Where should we put a glyph? We'll put it above the. Where should we put it? Should we get it to follow the sphere, or should we put it like? Let's put it here, right? Let's put one there, because it's just the most simplest thing. So we'll put it. So it's got to go in front of the green one. This is the green one. Do glyph. So basically we'll render it like, so we've got 8 by 8 pixels. Let's do 32 by, wait, it's 10, isn't it? Yeah, so let's do 40 40. And then, so the center position, so if it's 200 tall, if the green one is 200 tall, obviously you want to go up like a quarter up, is that right? Yeah. So you go up by about 50, right? So we add 50, and then that ought to be good enough. So we also got a bit of a color here as well, which could be interesting. We can have a bit of play with that. Let's not make it green. Let's make it red. Let's not make it red. Let's make it pink because I'm a very imaginative person. You can do cool DOS graphics with extended ASCII. Yeah. The extended ASCII is like, I think there's many different versions of it, isn't there? Behind the sphere. Hey, the robot. How you doing? Welcome, welcome. Yeah, it's a circle though. Sphere's a 3D, my friend. Yeah, I don't know. I've got too much layered here. I would rather. Oh, I could put it in. Yeah, behind. Oh, that's a good idea. Behind. See, robots got all these good ideas. You see, in front of this thing, but behind this thing. Hmm. 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 That's a good idea. So screw that 50 into oblivion. So we don't want it pink then. Let's just do the really horrible blue. We'll do that one. So right, that's everything in the CPU side. Now we've just got to do the GPU stuff. So how do we do it? Well, basically, and also how did this work? I think my C compiler automatically puts a scope in there, so it's kind of like C23 ready. But anyway, it was the easiest thing to do, I think. So that's why I did it that way. Anyway, so it's basically the texture one, but what's the but? Um, but instead of being a texture, the texture's hard coded, right? So you're passing in a glyph, right? So again, we probably just want to. Why aren't you smart enough? Right. We probably just want to right, glyph index. We'll do a glyph index, convert that into a UV thingy, and obviously this is getting a bit big. We can kind of reuse some of the same fields here, really, but yeah, things. So in our constants that get uploaded to the shader, UI render, we want to add a read-only texture, and this is going to be the font. So what we're going to do is use that font texture. So CPU side, we won't really finish, will we? Font texture equal ggfx dot font texture ID. That'll set all that up and be ready to use in the shader. So then in the shader, we can now work out the UV. So how do you work out the UV? So you still do this sort of like -1 or 0 to 1 thing, right? But then you kind of want to you want to offset it and scale it accordingly into that sort of 16 by 16 texture, right? So how do you scale that accordingly? So you've got a glyph index, so you kind of need to turn that probably into a coordinate, and then you want to so you scale it down to 16 by 6. So your UV is going from 0 to 1. Then you probably just want to the texture is 160 or something like that, isn't it? So we could probably have that passed in, how big is this font texture? Dims, something like that. Then, so those are the dimensions, and then you probably want to have right, sketch up a chat. Foo. The color, maybe. Yeah, I think that's green. Yeah, I've already got green in there. UV. So UV 0 to 1. We then need to turn it into as if it's going from right, so you've got the size in pixels, which means you got the size of the texture in pixels. So you can get the size of a pixel in UV space, and then you kind of want to and then you can know how many is 16 pixels in UV space, and then you should just be able to scale it, multiply it by that, right? And then you just need to offset it by that as well. So we can probably just do this in the shader every pixel. Obviously it'd be faster to pass this in pre-calculated, but when we change this to be more of a cached font atlas thing, right? A glyph atlas thing, we probably are gonna have this calculated in the shader anyway, maybe, or something like no. we'll have the UVs like passed in or something like this. So for now, this is just going to be well, yeah, if we're gonna have them passed in anyway. Um, yeah, why don't we just do that? Yeah, but then there's gonna be like a size, isn't it? Because you're gonna have like, is that right? Um, because you kind of need to know how big is the glyph. Hmm. Yeah, you might need the glyph size as well. Isn't it in 0 to 1 space? Yeah, it will be in 0 to 1 space, but I think we need. Hmm. Yeah, so this is currently 0 to 1 to see whether it's. So we've got like a box. Imagine this box here. And we've got like a 0 down here, and 0 0 down here, and 1 1 up here. Um, and then we need to map that into the texture, which would be the font atlas, basically. So, um, I'm trying to think. In the future, we're just going to be passing probably. So we get up this thing here. It blur. Okay, it doesn't blur. That's good. So obviously down here is 0 0. Up here is 1 1. So when you're referring, imagine this whole box would just be like the G character. This is going to be like so 1 divided by 160 is that. So G on the X coordinate at least is going to go 1 2 3 4 5 6 7. So the X offset is going to be that, and then plus obviously the number it was before that. So yeah, we might, for the glyph at least, you probably just need a whole bounds. Do you need like hmm. Yeah, you probably need like a scale and an offset basically. Like how big is this glyph in UV space? And how big is the like how do you scale it? Yeah, and the offset in UV space as well. We'll probably need that in the future. So let's just put it in here as well. It's going to make this big, but who cares? We can definitely share a lot of this data anyway. UV offset, UV scale, something like that. Could do something like this in the shader. Glyph index is 0, 2 for 5. Yeah, I was thinking about doing that, that's for sure. But then I was thinking like how's it going to be? And we are going to be passing it in. When we do like a font map anyway. So I was just gonna, you know. But yeah, that if we was doing this like only using pre-rastered fonts at fixed sizes, that is definitely the route I would have gone. It's a good way of doing it. So in this case, it'd be like command glyph scale, UV scale. So it'd be like UV equal mol F32 times 2 UV, right? And then you offset it. Add. Okay. So, right, let's do it. So that should be it. We want to go up into the top and actually, well, we've got these little commands now and set that up. So it's like glyph UV offset. So we kind of had a number here. Always reworking out. So we'll do a, you know, the best character in the alphabet. Right, where's the capital H? So that is 8 over 8. Yeah. So 1 divided by 16 is that number there. So that's your scale. Glyph UV scale. F32 times 2. 625, something like that, 0. Yeah. 625.f. Oh. Cool. And the next one is, oh wait, why did I not do dot? Okay. Now the offset is obviously a multiple of this, so I'll just do like times. Well, all right, times 8. And how many down are we going by? 4. All right. Let's try that and see if we get that working. Right, it's redeclared. We'll do a nice scope thing here then to avoid that. Font texture is not declared in here because that is in BC. The constant's passed into the shader. And voila, right. Oh, we got a crash. Oh. Is it because we didn't set the size of the font? So put this font dims in here, but we didn't end up using it. I don't know if that was it. Right, still got the same crash. But it renders like a frame. Let's open up the log. We have, I wonder what we used in that Windows build. Oh well, I've got the log in here, let's just take a look at it. The log is saying one, 2 in gfx.c. Image data does not match. Right, so we added, right, I see. So we've got this like static image data thing, which is just there just to sort of prove that the readback is working. Yeah, that's all it is. Sweet, but I don't see anything working. So why work is the question. So the first thing to do would be just to render a black box. So first of all, we're just going to set the, let's comment out that. Let's see if it works. Right, we're supposed to be on top of here, I think. So next thing we're going to be doing, okay, not black box then. Let's set, so this is obviously going to work, right? Must do. We're going to say equals, it's going to be fully white, right? So we'll do that last. Right, so I don't see anything, which is weird. So why is that? What have we done? Should we make this bigger? Maybe it's just too small. Let's just make it really big. Right, obviously make it really big, it kind of works. Let's make it half the size then. Or let's make it like a quarter of the size. Right, so we don't see it. So it must be because it's behind the logo. This must be because of that. We're correct. Didn't we want to put it in front of the box? So we order these draw commands front to back. And that's the way the render is going to work. Circle, glyph, rounded ABB texture. I think that's what we want to do. Right. Something is appearing, but it's obviously wrong. So the UVs are a bit wrong, I think. Let's have a think about that. Scale. So if you scale it, oh yeah, this 256 thing. Because we haven't got sampler support yet, so we hard coded the texture size. 160, wasn't it? There we go. Beautiful. So why isn't this thing bouncing? Well, the reason why it's not bouncing with alpha is because we've changed the order a little bit. So this has to be up by 1. That has to be up by 1 as well. And there we go. Now we've got a bit of a problem. And this is part of the reason why we've done a separate path for glyph and texture, is because, can you see that black border? Doesn't it just look horrible? So basically, we know, because of our texture, that black is transparent, white is not transparent. So really all we need to know is that. Now, if we just went more complicated, you're basically going to be sampling more of a smooth alpha value, right? So we're just going to check the R channel here. So, so instead this is going to be F32 alpha. And then you just say like dot R for red. And then with the alpha, what you can do, so you get the color here, source color dot A times equal alpha. And that ought to be good enough. Maybe not. Putri Fertos, thank you. Oh no, hey, how's it going? Welcome, welcome. Frank, I'm not using Dear I'm GUI, but yeah, I am going to be doing a ImGUI, right? Immediate mode UI. Yeah, that's what we're going to be doing. That's what we're going to be doing. But I'm just doing the rendering part of it first, so we can just wire that all in. So, alpha. Yeah, I don't know why it's doing that. So what we'll do is we'll do a thing. Let's just say then f32 times 4, alpha in the red channel, 0, 0, 1. So clearly that should be working, right? Because it's showing up red where the H is, and it's showing up black. So why you no work is the question. So when we say 1, 1, 1, alpha, or not even that, 0, 0, 0 alpha, whatever it needs to be, we see the H there, right? Bam, that's amazing. So why isn't the color working then? So if we bring this color out, like, is the color wrong? Are we changing the wrong color? One byte, 2 byte, 3 byte, 4 byte. Right, so that should be blue, right? The world's worst color. Oh, but it's a multiply. No? Yeah, it's a multiply. Oh, multiply from basically black. Or whatever it is. Yeah, that one, right. Okay. Oopsie. There we go. Horrible blue, everyone. Yay. Sweet. So, that's really good. I like it. You know, we should make it red instead. Because that is really horrible blue. It's kind of insane that just all blue is like really bad color. There we go. All red. Oof. I used to do UI streams, my custom engine should get back to them. And now a full UI system, event system. VBox, okay, I thought it said Xbox there because my screen sort of looks a bit weird. But yeah, VBox, HBox, scroll panel, text, split containers, etc. Very nice. Yeah, it's really cool when you get all that working. It is surprisingly a lot of work. Like, you know, also getting that scroll bar maths right as well. That's a fun one, right? But yeah. Obviously, when you have it done, it's copy paste in a lot of places. But yeah, good day. Hey there, Ransel. How you doing? Welcome, sir. With something like Nuclear or DMGUI, if you wanted to make nice looking UI, you pretty much have to rewrite your own widgets. Anyway. Yeah. Pretty true. Yeah, it's, you know. Yeah. Yeah. People really find that those ways to sort of like overcomplicate UI systems as well. They get really, like, you know, they would like bring in the whole of the web browser to do a UI system in some places. Or if you just take a look at Microsoft's latest framework on their desktop using C#, it's just mind-boggling. They open sourced it, and I remember looking for the source code when they did, and it was just like, how did you manage that? That's what happens when you put like hundreds of people on a team to make software. It's just going to inherently get complicated. Um, right. Pretty good, right? So we could also finish this off properly. I do want to do some performance stuff, and then performance measuring. Um, but some of this stuff should really be addressed. The first one is sampler support. Like, just get that in, like, and get it working properly because it's we see. I don't know how much, or should we care about it? You know, we can just leave it. Yeah, yeah, yeah. Let's leave it. It'd be so much more fun if we just left it. And I don't think we're gonna actually be needing sampler support, maybe ever. Believe it or not. Maybe we can just get away with that. Maybe near the end. And obviously that UV thing to be calculated properly, yeah, should probably be done properly. But anyway, to-dos are the best. Yeah, it has become quite, you know, bloat, I guess. Yeah, there's quite a lot of stuff in it. And yeah, like with the I'm GUI, it was like one of the first big immediate mode UIs. So the API, as much as it is great and for like hacking together like debug stuff, it's not like the API could, it could do with a version 2 where it's like complete ground up a new version, right? That's obviously not compatible with the old one, and be much better. But I think he does a lot of like rewrites for it though. Like he rewrote like the table API or something, um, which made it kind of more complicated, I think. But yeah, it's very powerful though. You like nuclear, though I think it's perfect for smaller projects, etc. Cool. Orchestra season aside, it's late nights every weekend. Weekday, fair play. Busy man, Ransel, I see. Busy man. Right. What's the next thing we're going to be doing? Making this go fast. But before we make it go fast, we need to sort of get metrics, right? Because we could just be like, oh yeah, this is fast because of this reason. Or this is going to be faster because I'm doing this. But then you're not actually seeing how fast it is. So we're going to be getting data on how quick this shader is actually running. So a quick refresh on how this shader works. Per pixel, it goes over every draw command and basically renders it. So it goes front to back. So it goes circle, that red H glyph, then the purple rounded corners, and then this guy. For every pixel, it goes over them. As soon as that pixel hits something that is fully opaque, it just breaks out the for loop and doesn't try to render anything else. But that's how we get to do the alpha blending front to back. And yeah, so obviously, if you have a very busy screen, you've got yourself thousands of draw commands. So it's going to be really bad. And those compute shaders are going to run for a long time, and it's going to take a while. So what we want to do is obviously do an optimization to that, which people can probably guess what that is. But I want to see how fast it is. So what we're going to do is we're going to get a measurement now, or get the performance stuff into measure it all. Do a whole screen filled with glyphs and all sorts of stuff. And then see what sort of numbers we get. And then optimize it and see what numbers we get after. Oh, robot, look at that man. He knows. Yeah, tile based. So we'll be doing a compute shader runs before that bins it into tiles, yeah, basically. The docking branch is cool, but pretty hard to deal with in practice. I tried it. Fair play. Yeah, and also the docking branch, it's been in like the experimental branch for ages, and I'm sure tons of companies are using that. What theme was it that you took and modified? I'm doing the same thing. Um, I forgot it was. I'll take a gander. But I need to be right back because I'm busting for the loo. And I'm going to also get another drink. Wait, let's get that music going again. So yeah, I'll be back in 2 secs and I will fetch that theme there, Ransel. Right, so enjoy the tunes. Oh, welcome back. Right, I want to listen to this music as well. Huh. Right, so Ransel wanted to know the theme that I sort of based my theme off of and made it better. Where's the colors and all that jazz? Ah, no. Gotcha. It's called Ascent. So yeah, I took the colors from it because they'd done the background theme and then I extended it to all those. Yeah. Right, so what's the plan now? We've already been over it, right? So, so how do you get metrics from the GPU, eh? So what we kind of want to do, right? So I imagine in the future, we might want to take this performance data and do something with it. So in our GPU API, we probably want to have some form of just give me performance data, please, type of thing. So why don't we build that, and then we're just going to throw it out into the terminal or something. But in future, we could build a way to sort of visualize this in the game or something, and render it better. So essentially, what we want to be able to do is. So we just want like a list of like entries basically. It's GPU profile entry. And we just basically want to let the name of the shader, which we can get, that was ran, on that. And we also want to have like it's a core string, probably get one of those. So I like the name. We also, and then we want to have something like a U64 of like time start in nanoseconds and time end in nanoseconds, because that's what GPUs report, right, in some nanosecond type of timing. And then we can just display this somehow. So let's just maybe should I call it like profile info? So with this profile info, what I imagine it's going to do so I'm just trying to think how it's going to allocate the name. Like there is going to be like probably like we have like a temporary allocator which lasts a frame, but we probably want to we'll ask you for an allocator, and then we'll fill it up, copy the strings over, yeah, something like that. And so basically you just get an array of entries. Something like that. That's what I imagine we want. And then we can just say, right, void GPU profile So I think there's a bit of latency. So when you go, hey, can I get the latest profile information? You'll get the one from like 2 frames ago. So I think you want to say like profile start, profile stop or finish. Start stop. Then we just do a get. And then you probably want to have like a custom allocator to allocate that memory, because you're going to have a render thread and you might want to pass this between threads, I imagine. So yeah, we'll do that. So we'll just get the front end of this in, and then we'll write the back end stuff. Source GPU C. So let's find the dispatch. Here's the profile. So I don't know what the info get is going to look like, to be honest. So we'll just do something base empty, kind of empty, right? That needs to return a boolean to say whether or not you actually got something, because you may have just started it. Basically, right? Cool. So we'll just return false for now. So when you start, we're just going to set a global. So we'll say have a little boolean. We'll say something like is profiling GPU is profiling, and then equal false. And then obviously you want to do that super nice assertions where you just say debug assert for me please that is profiling is not profiling. Profiling has already started. We can kind of probably ignore that, to be honest, but I guess it's good just for correctness, maybe. Something like that. Cool. So for this one, it's probably going to call and get, yeah. So I imagine while this boolean is on, in the back end, when we submit or when we start a frame, I forget which one it is, but we need to like pull back the profile data, and then we need to basically store it in an array of GPU profile info. So we can temporarily allocate that array. We can fill it in. That could then be set in the... Wait, can we temporarily allocate it? So after we call submit, maybe you can then do a get, and then the pointer would be available. And then you can copy that out, or something like that. Yeah. So I reckon we're gonna have a little array then of this profile info. And yeah. See, we just want to like copy that out somehow. You know, but for now, we'll just say like info equal ggpu, because we don't need anything more complicated than that, and that'll just be more effort. So we'll say to do when we multi-thread the game, make sure we copy this out. Make sure we deep copy. Something like that, yeah. Let me just say core unused variable, which is this allocator thing. Cool. So that's the front end for now. So we just got to fill in this GPU info in the back end. So in the Vulkan code, what do we need to do? So there's these functions called like timestamp something, vk command timestamp something like that. So we've got to find it. So user include Vulkan core. Yeah, so we need a query pool. This is it. So vk command write timestamp. So you basically write a timestamp before the command and a timestamp after the command, and then you can use, then you can read back from the query pool. So first of all, let's make a query pool. So a query pool is basically just like, it's essentially, I think you want to double buffer these or something. I forgot what it is. Let's just have a bit of a gander. Right. Yeah, so we'll have one of these per submit, basically, I think. Shouldn't be too hard. Source GPU. So a query pool is something where you like, where the timestamps get written to, and then the CPU can read them back, basically. Yeah, that's the one. So they'll bathe. Ooh. Yeah, I want to go to the internals. So we basically load all the function pointers in Vulkan because it is the way. So let's get all those function pointers in. So on the function pointer for query pool, destroy query pool. So there's a get query pool results. I think that's the one you want to use. There is another one, but that one is like basically the so you can get it. You can copy the query pool results to a buffer, and then basically map the buffer CPU side, but that requires far more effort. This one's just easier to implement. Okay. Yep. And then we also want to get the command timestamp, right timestamp. So reset query pool. It's all these buggers. Hey there, G Moss. How you doing? Welcome, welcome. End query. There's just so many functions. So thank you, Vulkan. All these functions are just making my day right now. Right, so all the functions. So obviously I could put them in that order, but then really like, you kind of want to put them next to each other because they end up going into one big structure. So I want to like just make it a little bit more cache efficient, basically. So I put the create and destroys next to each other. I guess that's what I thought I did. Right, suppose create and destroys next to each other. Bam. Then all the command buffer stuff needs to stay next to each other. Cool. Those can just stay down there. Right. So now that we've got the functions available, now we can actually set this up. So basically, we have our command buffer. They're somewhere, right? They're here, command buffers. So you want to have some query pools in here. One per command buffer. Something like that. So when we initialize these guys, we'll initialize the... So we only really have one command buffer per frame because that's all we need because it's in compute only. But if you do something more complex, you're going to need like multiple command buffers because that's the way Vulkan likes to do sync code, unfortunately. Or synchronization in some aspect. Awesome, good to hear. Yeah, not too bad, not too bad. We've got our GPU rendering code working for UI. Basically, we've got everything here. Got boxes, got glyphs, got spheres, got an image rendering. So yeah, we're just working on profiling this, and then we're gonna make it better. And yeah, so that's what we're doing today. Yeah, things are going good though. Gotta make stuff. Gotta make it visual before we actually program the rest of it. Right? It'd be nicer. So we're not really making an engine, but we are. Um, so the basic answer is we're running a game, but we're running it all from scratch. So obviously I need to write the engine part as well. But yeah, so we're cutting corners basically wherever possible. The reason why we're running a game about an engine is because you can just spend all the time in the world making an engine and you never make a game. So we're trying out something where you just make the game. But obviously I need to do some engine bits. But yeah, also the other part thing is like what happens if you basically had no dependencies, and you're making code specific for a game. Because part of the problem is you can make your engine and you've got to make like 5 games off this thing, or prototypes, whatever. It turns out you want to rewrite some part of the engine. Now guess what? You got to make that same engine work across all those past games if you want to bring those forward. Whereas if you sort of like just say no, the code is specific for that game, then you don't have that problem anymore of maintaining older projects in that way. But the code is built specific for that game. So if you need to put a fix in there, you can just do it. If you need to architect something in a specific way for that game, you can just do it. So these are the things we're sort of like playing around with because I've never done it this way before. So yeah, that's the plan. That is the plan. Query pull. Great query pull, of course it was. Alright, let's fill in this guy. Cool. What goes in here? Got any flags? What are your flags? No flags. Flags are 0. Shocker. What is the query pull type? So the type of this query pull is the timestamp one, please. So obviously you can actually get more like, you can gather like pipeline statistics, which I think is like how long did it take to compile or whatever. I don't know. I've not used it for that, so. Also get collision queries as well. Query count, right? How many queries are we going to be doing? So the thing is we kind of like don't really have a number. So for now, I don't know what we did. Because we just record directly into a command buffer. We don't have like a, like a work graph at all or anything like that. So we don't really pre-allocate an array of like, we don't have like a intermediate command buffer in any way. So maybe I don't know, what do we want to do? Yeah, I think we'll put it, we'll just call it like command buffer commands capacity. We'll just say like 1024 because you have like one of those per command basically, right? And this the pipeline statistic flags is 0 because it's obviously just for timestamp. So we make 2 of these. Did I start overwriting something that I shouldn't have? Classic. Undo all that. Active frames, right? Oh yeah. Right, so then we just want to do one of these sort of GPU Vulkan asserts, call the create function, and then voila. Ugh. Right, so that will create the query pause. So that does summon, it's just like all we're trying to do is get timestamps here, and you'll realize that just how complicated Vulkan is. Every time you're gonna do something, it's like we got this thing over here, you got this thing over here, and this thing over here, and these all do different things but work together, and you got to use them all. Like, thank you, Vulkan. But yeah. I'm all about writing once and reusing everything possible. Write once is never true, but reuse. Yeah, but that's the same thing without. You can still reuse code. Like, you don't have to write from scratch. Part of me writing this from scratch though is because like, one, I wanted to like stream it being written from scratch. Two, like I kind of like I'm not a fan of the previous code and like of well no I have we have looked at previous code and we have copied some and pasted some over. But yeah, I didn't like the architecture of it, so it got redone. And that is probably going to happen anyway, right? When you do your reused code anyway, you just rewrite it because you're not a fan of the architecture. Never been good for beginner programmers. I don't know, maybe. I'm not sure. If you're just learning like the programming concepts, probably not. Yeah, Vulkan's complicated. I don't want to rewrite from scratch using event coding with every project to do, for example. Yeah, I think there is a fair point with some utility libraries, like maybe like loading a PNG image. Like you can have those in little libraries, but where there's like specifics for a project, um, and that's where you want to write something more specific, like you know, someone who's not done too much programming might think like, or someone who is at the beginning of doing their programming might think, oh, obviously a user interface is a reusable component, right? But then like really if you look at projects is they a lot of the time they want a specific way of doing UI for their project. So maybe using a pre-rolled like one that's shared across multiple applications isn't really the best idea, but it can work, right? Sorry, but it does work doing it that way. That's what I mean to say. Right, so we've got the query pool. So what's the next thing we need to do? So you need to begin the query pool and then you need to end the query pool. So you only need to do this. Yeah, begin query, end query. So you need to do this like when you start the command buffer basically. So begin command buffer. So we do that when we do frame start. So we say if we got a GPU is profiling. We call this lovely, and this lovely returns a void. So absolutely nothing. So we pass in our VK command buffer. I want to use the function pointers, don't mind me. Then we want to query, pass in the query pool. VK query pools. Active frame index, that'll go flip between 0 and 1 every frame. What does query do? What do you do with that one? I forgot now. I'll read the docs. The query index within the pool that will contain the results. After getting the query, so I think you just say 0, right? So it's like the start index, because you can basically have one big query pool and just sort of tell it to, but we've just done multiple query pools, so I think we should just say 0. I think that's what it's saying basically. Then what are the flags? Well, they're probably just gonna be 0. That's for occlusion queries, so nothing. Very nice. So then at the end, when you say VK end, we're also going to say end. I don't know what end does. Let's have a look at that one. I might need to look at an implementation of this actually, because I might need to look at an example. They've done a query count of 1. Yeah, I'm not sure what this is really trying to say, to be fair. Not occlusion query. Vulkan timestamp. Right. Let's remember how this API works. What about the query pool? Pools are pretty straightforward. Query type should be timestamp, and the count should be equal to the number of timestamps you need. Yeah. So we're right by that then. So when you say begin, great, that's not helping us. Maybe you don't need begin query then. No, you must do. No, you need begin query. I think it might be ignored. I've read the docs a little bit more. What about timestamp? Query type must not be timestamp. Right, so you just don't use it. Sweet. Well, not sweet, we just wrote it, but you know. That's fine. So we keep this sort of like is profiling thing. Right, so basically when we do a dispatch, we just want to say, hey, we're profiling. Can you write me one of those, let's get rid of these. Can you write me one of those timestamps, please? So 0 for the stage flags, query pool, gotcha right there, that's good. And then the query index. So the thing is, what we want to do is record. We want to be recording like 2 timestamps per right, 2 timestamps per dispatch. So really what you want to do is probably like, so you're probably going to be double buffering. So the thing with double buffering these, right? So while I'm building this frame, the GPU is running the other frame. And then I shall copy these results at some point back to the higher level place. So we probably can just store here like the query counts, something like this, right? So the query counts can kind of get reset at the start. So where the begin command buffer thing is, we'll say, hey, query counts ggpvk.query counts active frame index equals 0. So what we'll be doing is just taking that and upping it by 2 or something, or just by 1. Something like that at least. So we need to go back to like timestamp. So here we'll say like, oh, what is the so here we'll just say query index. And I think that's a good one. So that'd be the timestamp that goes before. Wait, did I do something wrong? Oh, sorry, I missed the stage flags. I thought it was someone else. No, these need to be here. So you need to say top of pipe, bottom of pipe. Wait. Pipeline stage. Right, so what we're doing. Okay, is there a right timestamp too? I don't know if that really matters much. Yeah, right timestamp 2 would be better. So you get this pipeline stages 2. It's more. It's more up to date at least. It's more. There's more options. So for this one, so I'm not sure if it's really going to help us, but it might do in future. We want to say so you do dispatch. We're just gonna have dispatch. We might say, yeah, I think let's just say this compute. I think that'll work fine. It might not. You might have to say top of pipe, bottom of pipe, but we'll give it a go, see how it. Maybe we should read the docs. Specifying the stage of the pipeline. Yeah, I know Vulkan's gonna be like documentation, and then it'll just give you like some really vague idea of what it's saying. So the first synchronization scope includes all commands that occur earlier on in submission order. Is it kind of LSP for Vulkan or just on your own in that regard? I don't know. Like there's an LSP for C, right? And you just include the header and you just have all the stuff available, right? But yeah, I guess I just don't really know how to take full advantage of it, and it kind of goes a bit wrong anyway in C a lot of the time. But yeah. The first synchronization scope includes all commands that occur earlier, so before, in submission order. The second synchronization scope includes only the timestamp write operation. Oh wait, I didn't read the bit before. When command write timestamp is submitted onto a queue, it defines an execution dependency on commands that were submitted before it and writes a timestamp to the query pool. So you need to kind of specify the stuff happens before it. Any timestamp writes that happen after in the same submission must not have a lower value because the value is fine. Right. So it must not be none. Oh no, it can be none. So we could just do top of pipe, bottom of pipe. I'm not sure. Yeah, I think top of pipe, bottom of pipe should be fine. The top of pipe before, and then compute shader. Yep, that's it. Right, so this would mean then. Yep. That's good. That's good. That's good. That's good. Right. So this means we're writing timestamps in now. So that's everything set up in terms of like creating the query pools and then writing timestamps, but we're missing one final thing, and that is actually reading the results back. So for that, there's one more thing, and that is get query pool results, right? So it's this hefty bugger. So we kind of want to get like right. So where are we doing this? So we're building up a bunch of counts, and right. So let's think about this. Yeah. So when you begin your frame, what you want to do is say, right. If we're profiling, when you begin your frame, if we're profiling, we check to see if there's any query counts. If there is, we read them back and then we reset it. And then, so right here, if ggpuv is profiling, so if we're profiling, we call this bugger in. Oh, wait a minute, I've got to do the ggpvk thing. There we go. Right, so the device, which would be ggpuvk.vk device. What's the query pool? So that is GGPU VK query pool. So we're reading back the current query pool, though we're going to be using this frame, but we're just reading back the one which happened 2 frames ago. If queries count, and then we read, and then so first query is 0, then the number of queries, then, and also just spell query counts. It's kind of just query, right? After that's the data size. So you can read back like 64-bit ints, which we want to do. So there's in this blog here, they do say that. They do mention that. Wait, I want to read that top pipe, bottom pipe thing. Well, maybe we got that wrong. Let's read that back. Right. Result 64, we want that. Besides the usual blah blah blah, it accepts p-data size, some stride, and flags. Size of buffer is a stride, depends on the flag. Possible variants are... Yeah, so on the 64-bit data, we want this one. So this result weight thing, we'll look at that. Right, so we'll say like size, data, get to that in a sec. Then the stride, finally the flags, effort. We probably want to awe some more on, so let's just read them. So there's a result weight. I don't think we want that actually, because we would have weighted ourselves anyway, but maybe. This can be used instead. In this case, each frame you check if the value is available on the host, and don't issue a new write command until you read previous. So it's quite possible some frames have been missed. And here are the rules for this flag. In addition to the query value and special availability is written after I'm not sure on with the availability thing. Don't think we need that bit either. So I think what we need is just that one actually. So the size we're trying to read back. So the size we're trying to read back is number of queries times U64 times yeah, so it's just like size equal query count times size of U64. Then we allocate our timestamps. So this would be core. Oh, we've got a frame alloc in here. Allocate. Oh, got one. Good. So we're gonna say alloc array U64. Frame allocator is a temporary allocator, nice and quick. And we allocate query count worth of those. Then timestamps goes in there. Now the stride, I don't know if you can stick a 0 in there. Yeah, so I guess the stride per query is just size of U64. Because you can have gaps, right? Imagine if you write in a structure, you can get it to write into a specific field of that structure, basically, with stride. Which we might actually use, I don't know yet. Right, I think that's good enough. So let's quickly just read that bottom thing with the whole bottom of pipe thing. Says write timestamp. So top of pipe says write timestamp as soon as all the previous commands been taken by the command processor. Write timestamp as soon as all previous commands tire. Yes, maybe we do on bottom of pipe then. Bottom of pipe. I guess it doesn't matter because we only issued dispatch anyway, but whatever. Right. So what are we trying to do now? So we've done the query, like read. Right. So now we've got this results thing. It does return a result. So with this VK result, there's a thing that we can look at. So with the results, it will tell us if, okay, it tells us if it's not ready. So, okay, so we want to do that standard assertion, but we also want our assert to say if it's not ready, because that's kind of a success message still. And this assert here just kind of checks for errors. So we also want to do another assert. Expected to be ready since we actually, well, yeah, since we wait for the GPU. Before this code. Cool. So here is where we can actually now copy it into the right place. So we've got that sort of profile info structure. Now, we don't actually know the names of these things. We have a start and an end, which is pretty cool. But we don't have a name at all. So what we should probably do right, so where are these names? Yeah, so I think in the Vulkan internal, we probably want to have like a temporary, like, right, so I guess we'll just do another one of these where we'll probably just have like, can I just have a pointer to a bunch of strings. Right, this is going to be your query names or whatever. Something like that. So when we make our query pool, we're also going to pre-allocate all those names. I guess they could just be static. So say ggpvk, this thing, so that would be a core alloc array, core string. We have a static allocator, I think, dot about somewhere. Yeah, it should be in the same function. And then we obviously want to allocate the number of command buffers for those there, like that. Cool. Index, very nice. All right, let's get that music going. Okay. So now we've got these two arrays of names. We can actually fill those in every time we do a timestamp recording. So when we do this dispatch, we have the shader here. Now, we should also have the shader names. So what we should be able to do, it's a bit silly, but I think we can just do this, right? So query names, query index divided by 2. Yeah, it'd be fun. Equals, now, I think there's a HCC shader names. Shader infos, shader dot name. Ta-da. I think that will be good enough. So basically when we compile our shaders, we generate some metadata. Here it is. We compile that into the game. I don't know how good this is. It's really a big test. It seems good enough for a lot of things. We've also got some ways to maybe automatically do synchronization code in some ways, because we basically give reflection information on different structures and what resources they have. Like they have a texture here that's write only, and they have a texture that's read only, and they're offset in the structures, so you can sort of like fish that out and possibly do synchronization code. But we haven't done that yet because it would be a little bit more effort, and it's just quite easy to do. Like I've done a version of the API where I could automate it on top of the one we have right now, basically. But yeah, so for now we've just got this array of shader infos, and we can literally just like grab the name. So that'd be dead handy, you know. So it should be as easy as that, really. Core string from a C string, please. Damn it. See, it's kind of like in a certain place. Yeah. So here we should really include the wait a minute. HCC interop. I think it is in. Yep. So that's declared in. Oh no, it's not. Right. Where do we get the metadata? Oh, it's right there. Oh, discards qualifiers. Alright, it's a different thing. IntelliSense is a bit bugged up, I think. Sweet. So now we're poking the name in there. That's it. Good. So now what we want to do is when we pull back these results, we need to build the arrays. See, what I might do then, see this profile info thing, I might for now, yeah, just pre-allocate that at the beginning. It will just do for now. So we'll just say, right, GPU dot profile info dot entries equals, and then we just do some static allocation again. So an array of GPU profile entry from static allocator. And we want, where's that constant that we had? Very nice. So we just allocate that once, and the entry's capacity can be set every time. So when we read it back, here we go. So now we can actually turn this data into that profile entries. So basically we've got 2 timestamps per, so we could just record this directly into it, to be honest. Rather than temporary allocate and then copying it again, we could just chuck it right into there, you know? Is there anything to do with stride? No. Stride is different, good. So that means we could technically just stride it by profile entry, right? And then the timestamps will literally just be like ggpu dot entries dot. Yeah, but that's striding every. Because we take 1 timestamp before, 1 timestamp after. Yeah, that's not going to be good. Ain't going to work. That's fine. Right, so now we're going to do a for loop over the number of commands. That's query divided by 2, because 2 timestamps per command. 0 to commands count. Cool, so what we need to do is say GPU profile entry. Entry equal the address of GPU. Profile info, command index, entry name. So that name is stored in that nice little array we've got in the Vulkan backend, called like query names. So command index, the active frame index in there as well. I think we need to set the count. Sweet. So we set the name, then we just need to set the timestamp start and the timestamp end. So this one is going to be timestamps command index times 2 plus 0. And this one is times 2 plus 1. There you go. Cool, so I think we've done it now. Obviously we've got to get it compiling and write the front end code to actually like print this out. But I think we're filling out these entries and I think it should just work just fine. So this gets reset every single time what we call frame start. Okay, so when we start a frame, it's going to be like, has the GPU got us any profiling information? If it has, it will copy it to that place. Wait, where's that? 2 seconds. GPU profile entries count equals 0. Good thing, we'll reset to 0. Right, so if it has profile information, it'll fetch it, read it back into that profile infos, and then basically we can use that until we call this again, right? Yep. So in terms of profiling, I guess we're just gonna start it. We might want another Boolean to say is running. But maybe equally you could just say, you could just do a get, and the get will just like say if not is profiling, we just return false. Something like that. That'll be good. So then what we can do is start, just do a start on initialize. GPU profile start. And we can just comment that out whenever we want. Oh, my chat's gone on my phone for some reason. Alright, stream seems good. Oh, my phone's Wi-Fi is gone. Isn't that fantastic? Let's reboot that. Right, so when we do that frame, I already did frame start. When we do, I guess we can do it here. If, so you do sort of like GPU profile info. Should we just print out in the terminal for now? Alright, let's just find my stream again and get that chat back open. There we go, the chat's back open now. So we just say, right, if GPU profile info get address of profile information, and then some allocator. We'll just use a frame allocator, I don't know. Hopefully that just compiles. Maybe not. Core I allocator, frame allocator, game, TLS, frame allocator. Fantastic. Right. What? No, that exists. Where is that? Oh, game.h, sure, put it in there. Right, anyway. So, We just want to see if, like, we just want to get in here, right? Let's just do the for loop. Let's do the for loop. Let's just write it out. So we just want to display printf for now. Like we could just write out to a file every time and just look at that file instead. But yeah, I think we will do that in a second. Let's just do that. So we're going from index 0 to profile info dot entries count, and then we're just literally going to say like printf name. We didn't have to do a name, right? So it's in nanoseconds. So if you want to display this, we display it in ms. F to F, and you say like ms. It'll be fixed width, and then you do the name, because that'd be variable width, right? So we'll say start ms, end ms, profile info dot entries. Okay, I need to get the entry. Index, fantastic. Right, let's take the address of that. Bam. So how do we work out this start ms? So it's in nanoseconds as a U64. So oh my days, I completely missed out on something. There's a period. It's called period. Is the number of nanoseconds required for a timestamp query to be incremented by 1. Sometimes this is 1. Right. Um, right. So we need to multiply this by ggpu Vulkan, because I already prefetched those properties, limits, timestamp period, I think. Oh, it's floating point, is it? Right, we'll sort that out. So, right, double, so F64, right? And then you want to cast it overall into like a U64. So the timestamp is in some format. This timestamp period is in a float format. So you need to multiply your timestamp by timestamp period. That gets you to a nanosecond. Is the time in nanoseconds we need to multiply that difference by? It's not really the difference, just by anything by. The number of nanoseconds required for a timestamp query to be incremented by 1. Fantastic. Something like that. So now it's actually done in nanoseconds properly. So back to where we were in the code was printing this out. So turn it to milliseconds. It's as simple as like cast to float 64. Then you say entry start index. Sorry, start nanoseconds. Multiply by 1,000. Right, because it's micro then milli. Nano, micro, milli. Yeah, so it's actually by 10,000. By 100,000 or million, sorry. 1, 2, 3. There we go. So that's why we do double as well. Cool. Milliseconds maybe. Maybe it's not good enough. Oh, divide. That's right. Thank you, no idea. I'm the one who has no idea. Right, and then that wants to be a format string as well. Oh yeah. Right, all compiles. So get ready for it to blow up. So that doesn't blow up. It prints profile, but it doesn't give us anything for some reason. This is interesting. So do we land here? We don't land there apparently, which means we don't have any query counts. So are we profiling? That is the question. Apparently his profiling is a 0. Why? What? Oh, sorry, if 0 the profile start like an absolute plonker. Ugh, right. Rightio. Hey there, Captain Chica. How you doing? Alright, let's see this. This is probably a crash, right? Some infinite loop. Potentially. Do a break. And we land. Do a validation error. What? So we're trying to get the stack trace and it's like, no. I don't know why we're getting an infinite loop here, you know? It's bizarre. Fantastic. After boosting on Linux, after dealing with Microsoft bullcrap for about 2 weeks straight. Yeah, I know, right? We did a similar sort of thing. We did Windows Dev for a bit. but we're back. I don't know what I've done with this code. And why is it broken now? Because we had Vulkan validation, messages, stack traces, all that good stuff, and it doesn't want to work anymore. So, so we have got a system where if we do an abort, it will just tell us, right? But we kind of want to display the message, so really that should be logged. Like, so first of all, let's just test this, right? Let's just say like, oh, Vulkan, and let's just see if that'll so why can't I get a stack trace inside? Why can't I get a stack trace inside the this callback here? Let's try it here. That works. So it's nothing to do with anything with files or anything, but then why? Let's say 0 here. See if it fixes it. Just saying the number to just pop off the top. Nope. Why doesn't it want to do it? It works in GDB though. But want to follow your follow a game dev playlist, but got intimidated by I don't know. That's some good advice. Because I don't know, a build to SH is the simplest thing, right? So if you've been intimidated by that, something is like quite a lot is missing. Like build systems, I can see why you've been intimidated by them. They are real bad, but this isn't complicated. It just builds a single file. But yeah, there are things to learn to do with like linking. Right, linking in C isn't easy sometimes to understand. But yeah. I'm not sure I have any advice to be honest because I'm quite tired. But maybe in another stream if you ask the same question I might have an answer. With recursive star C stuff, are you sure? No, just include all the file, just a single compilation unit. What? Why does my thing not want to give me? It used to work. You used to be able to stack trace and get you used to so you used to be able to get a stack trace, throw it into a log, and voila. But now you try and do it, and it's like I'm gonna freeze. Why? You get stuck on a read syscall. File underflow. So it runs ADDR2 line on what? On that VK layer Chronos crap. And I bet you that thing's a mega big file, but I don't know if that's a problem. But anyway, so it runs it on that. Wait, what line are we on? So it gets you a line. That's probably the previous line that was set. And then it's probably going down into the more lower levels of things. Yeah, it's only did a couple of them. F gets hangs. Good quote. First check, always check IO. Number of arguments. No. Yeah, something like that. If there are multiple child processes, perhaps popen is stuck. Interesting. Popen here. If there are multiple child processes, perhaps popen is stuck in a race condition such that FD isn't pointing to the right descriptor anymore. Right, usually you open with this one by default. Between child process spawns. Um... These are very good suggestions. Hmm. So he runs this address to line thing. So I've written this code before, and I didn't do fgets. This is part of the btrace library that we've been using. I forgot what I used to pull that out, to be honest. Maybe that code should be rewritten. But I don't understand what the problem is, that's the issue. Yeah, when reading popen. A simple fix in your case is to use logcookd. We'll send an ender file at the end of the current buffer, which allows fgets to continue instead of the default option, which only monitors the buffer endlessly. Right. Fgets reads hangs until it gets an ender file. No more data. And right end of the pipe is closed. So he's using logcat. Right, so something's crashing. So we could try and run this command, right? So that is simply just p command. Why don't we just run this, yeah? And see why it doesn't work. ADDR to line. So yeah, the funny thing is, if you only get a line number from an address, you use a you use a little application to do it, and then you parse the result back. Chronos dump validation -f capital C -p0x 16b 2032. Then they pipe error into null. We're not going to do that. We're just going to see what we get back. That just keeps running. And then we got it. But that took time, because it's a bloody big library. If you take a look at it, it's huge. So maybe if I hit continue, it does work. Oh. Is that really the whole problem? It's doing it many times in that library. That's why, isn't it? And it takes like 2 or more seconds each time. Yeah. Wow. Okay. Good one. So who wants to see how big that library is? Just about 500 megabytes. Yeah, just about 500 megabytes. Quite insane. It's big. Yeah. So same frames. So the error that we got is query pool's not been reset. Right, I missed the query pool reset. Let's do that. So we need to do that. Probably where you say query counts this thing. ggpvk. I guess you pass in the device in the query pool. GPU Oh no. It's on the command buffer. VK command buffer. Let's get that query pool just there. Bam, 0, and the number of queries. They're gonna reset. Cool. Right, it's gonna crash. So crazy C++ libraries. Right. So we need to reset it regardless. Right, that ought to do it. Oh yeah. Just look at that. So we're getting results back, but we're not this then. It's not right. The numbers aren't right, but it's very close, right? Very close. So let's just have a look at what's going on. So the first question is are we getting it will be divide, isn't it? Why didn't point F? First of all, that's wrong. I think it'll do promotion, so no, I'm right. We might need more precision. So if you're saying like the dot 3 would be how many after the place. So if you say divide by 1,000,000, you want 6 after the place, maybe. Something like that, I think. Maybe 7. Let's try 7 and see if it works, but I don't know if that's true. And if then we should really. Right. So the thing we'll do temporarily is let's pump in the end one only. And let's do ZU. And we'll just do, just this one here. And that number should be different. Right, it's just a bunch of zeros. Something's clearly wrong. So why is this one 0? So the first thing to check is like, so we're definitely setting this. The next thing is like, well, let's do a ZU 64-bit int. Let's try that out. So there are a bunch of zeros as well, and that's when you've pulled it back. Does that work? What is going on? That makes sure it's a success. Yeah, it says running over 3 times, right? Let's get the name. So the next question is like, okay, well, what is like this number here? Right, so that number's clearly going up and changing, which is great. So is timestamp period like 0? Because it sure feels like it, right? Oh man. So that's a float. It's literally 0. So we need to read up back timestamp period. I think it's right. Because we read back the physical properties. Do we not? Where's the physical property? Physical device. So I don't think we actually get the properties. Um, where is it? Get physical device properties. Really, we should be using get physical device properties too. But yeah, we'll just use the one for now. Because we haven't done the proper GPU setup code. Right, drop that in there. I can't believe we didn't set that up yet. Right, so that should be for proper now. And there we go. So we've got start and end. Good. But that's not what we want to see. What we want to really see is in this example here, is mainly just like how long does this thing take in MS. So what we really want is just like, you know, end MS takes start and MS, and voila. So, you know, to make it a bit quicker, it's probably just better if you just do this. MS, or like diff nanoseconds. Not that this probably matters, but you know, just as an example. Diff MS, then something like that. There you go. Cool. And there we go. So what we can now see is that we've got a frame initialize shader, which runs for 0.002/3 MS, right? So that is, let's get my bearings right. So that is about it's about 2 to 3 microseconds. This is about 10 microseconds to clear the screen. And then about 6.5 microseconds to render the UI so far. Now, it's obviously not very expensive yet, but we're going to be filling this screen with tons of little draw commands, as we call them. And remember, those draw commands execute per pixel. So we really want to see how slow does this get, and then apply our optimization on top and see how that goes. So yeah, that was pretty cool stream. So we've got the logo and this little like glyph working. And we've got this rounded corners working with AA, you know, anti-aliased edges, and a little profiler. So it's pretty sweet. So in the next stream, which will be on Thursday, 6:30 p.m. GMT, we're gonna blast a ton of stuff to the screen for the UI, and then we'll obviously write the optimized shader and bring that number all the way down again. Yeah, I'm gonna, as soon as this stream ends, I'm gonna upload the code to the GitLab so that the people who are following or who are subbed or who are subbed to Twitch or support Ko-Fi will be able to have a play with the code. And then, but also I'll upload it to YouTube as well, so it'll just be up there and you can watch it back. But also you can watch it back on Twitch as well, but I know it's probably better to watch it on YouTube anyway, but that's better. And also, cheers, thank you for the kind words. Cool. So let's find somebody to raid, and then I'll do all that stuff after that. Oh. See, I need to start following more people. Front page of Twitch. Let's raid this guy. I like raiding this guy. Do I kind of like a old school like boomer shooter, you know? Such a great genre, the boomer shooter. I love it. I actually do like it. Also, the name is just incredible. Right, let's raid this guy. That's right. Ayo. I missed it. What was that first recommended stream on the homepage? I don't know. Yeah, it's just Twitch for you. Just, you know, just crazy. It's funny because I literally just, you know, stream and watch the old programming stream and they just give you all that stuff, you know. Just silly. Anyways, alright. Have a good next couple of days. We'll see you all Thursday or Sunday. Have a good one. Right, thanks for coming, everyone. Bye.